All right, so we're going to be starting chapter 5, which is all about looking at polynomials and exponents and being able to work with different functions that have those. So exponents and polynomials. So we're going to lay the foundation today, our sort of essential questions here. We're going to talk about the different rules for exponents. So this will be a review. You've done a lot of this before, but making sure you understand how to work with exponents when you're doing different operations. And then our day 2, we'll talk about scientific notation. So we'll start with the rules here. First one's called the product rule. So if you multiply two things with the same base, what do you do with the exponent? So I'm going to give you an example to kind of go with these. But if you multiply with the same base, if we take a look, we add the exponents. We put those together. So for example, if you have like a to the 6th times a to the 3rd, we're going to put that together and think about how many a's are there all together? Well, if I have 6 of them plus 3 more of them, that would give me an a to the 9th. So I'm adding those together. So the product rule just means, hey, I get the total number. How many do I have all together? Quotient rule is very similar, but instead of adding the exponents, we subtract the exponents. So why is that? Well, when you're dividing, quotient means divide, remember, we are dividing out common factors. So I'll do that a to the 6th divided by a to the 3rd. Think about what that would mean. You're going to have a multiplied times itself 6 times, and then over a multiplied by itself 3 times. I can divide out common factors, 3 of these, and what I'm left with then is 3a's, so a to the 3rd. So the shortcut, the rule is take and subtract the exponents. So 6 minus 3, that gives us that a to the 3rd. So when you look at the rule, they say, yep, subtract the exponents. And remember, this only works if we have the same base, right? We can only put together those like terms. 0 exponent, anything to the 0 power. See if you remember that from before. Anything to the 0 power is 1. It goes back to that quotient rule. So I'm going to make up a new example. What if you had a to the 5th over a to the 5th? Now, if you use the rule we had before, we'd subtract the exponents. So a to the 5 minus 5 would be a to the 0 power. Now, it'd be sure nice to know what that is equal to. Well, if you have 5a's over 5a's, all of them divide out. Think about that for a second. If you take all 5a's divided by 5 more a's, every single of these divide out common factor and leave a factor of 1, which is why a to the 0 is 1. So just think of it as part of the quotient rule when you're looking at those. All right, we're going to talk about negative exponents now. So negative not as a negative number, but think negative as an opposite location. So negative exponents just means reciprocal. So if you see something like a to the negative n, it means 1 over a to the n. So for example, if you have a to the negative 3rd, that means the same as 1 over a to the 3rd. So this minus, that notation means, hey, you're actually dividing by that power of a, not multiplying by it. So a negative exponent. If you have a negative exponent in the denominator, we'll talk about that in a second, that comes up to the numerator. So that's a negative exponent. It means reciprocal. The power rules. So basically, these are all 3 different rules. If you have things like power to a power, what happens? So for this first one, a to the m to the n. Notice you only have one base, but you're raising it to 2 separate powers, like an a to the 3rd squared. Well, what does that mean? Well, if you square something, that means you times it by itself. So that's just the same thing as saying like a to the 3rd times a to the 3rd. If we use our previous product rule here, 3a's and 3a's would give me 6a's all together. So what's the shortcut? Well, how do you get from a 3 and a 2 to a 6? You multiply them. So it's m times n. So that power rule just says, hey, take whatever inside and raise it to that power. So power to a power, we multiply. Now, if you have multiplied things on the inside of a grouping symbol like this, it just means, again, take everything to that power on the outside. So no matter how many bases you have, you're going to raise each of them to that power. So like say you have 2 times x and you want to cube it. Well, that means you're going to have to cube the 2 and then also cube the x. You take everything on the inside and raise it to that power. Because remember what it means to cube something. That's like saying 2x times 2x times 2x. So that's 2 times 2 times 2, 2 cubed, and x times x times x, which is x cubed. So kind of makes sense if you think of it that way. Same thing if you divide. If you have division, you just take everything on the inside and raise it to that power. So the numerator would be raised to that power and the denominator. So we can do the top and the bottom separately. So for example, if we have x over 3 and you want to square that, that means you'd square the x and you would square the 3. So it means, again, you're multiplying x over 3 times itself 2 times. That's what it means to square something. So that's called the power rule. Basically means anything inside grouping symbols, hey, raise it to the power on the outside, whatever that is. Okay, some special rules with negative exponents here. Remember we talked about a negative exponent. If you have a to the negative n, it meant 1 over. Well, that means if you start with a negative exponent in the bottom, that means we do reciprocal. It goes to the top, so it equals a to the n. So I'll give you an example of that. So say you have 1 over x to the negative second. That's going to be x to the positive 2. So that negative means reciprocal. It goes in the opposite location. So what does that mean if you have two things that are negative? Well, if you have a negative in the numerator, look where the a to the n ends up. If you have a negative in the denominator, look at where it ends up. So you can have those top and bottom values, and they just mean it's reciprocal. It goes to the opposite location. So if I had an x to the negative second on top and a y to the negative third on the bottom, that would be the same as then, do reciprocal for both. So this x that was in the numerator would go to the denominator, the y that was in the bottom would go to the top. So just think anytime you see a negative exponent, it means reciprocal. It goes in the opposite location. All these not equal to zeros, just remember you can never have a zero in the denominator of a fraction when you're working with those. All right, so we're going to practice these. We're going to go through some examples and talk through. I'm going to have you pause the video a lot so you can try the question first and then check and see and listen to the explanation and see if you're right. So please always try these first and then so pause the video and then check your answers and see what you think. All right, so for this first one, m to the 8th times m to the 6th, double check, same base. So I'm multiplying with the same base. That's that product rule. I'm going to add the exponent. So this is the same as m to the 8 plus 6, which is m to the 14th. Now, I would never expect you to have to write the 8 plus 6, but that's what we're doing. If we wrote out what this actually meant, you would have 8 m's, however many that is, and then you have 6 more m's, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, and then we'd add up how many total we have all together, 14 of them. So it's just a shortcut way. You don't want to have to write out all of them. All right, take a look at letter B. Again, pause the video first, try it. All right, letter B, M and P, they are not like bases. So they are not like bases. That means it's already simplified. We can't do anything because if they're not the same base, I can't combine those. They're not like terms, so I can't do anything with that. That is already simplified. So please be aware, you got to make sure that you have the same base to be able to do these. All right, now we're going to do some of those product rules. So we're going to product and power rules, both of them actually. So if we have multiple terms like this, it's really a lot of sorting and organizing. So when I see things like this, they have parentheses because those are negative numbers. We can reorganize our multiplication. Think of it like the commutative property. So I'm going to put the number parts and then I'm going to put the variable parts. So sometimes it helps even if you do this in your head and don't write them. So we're multiplying the coefficient parts. So negative times a negative, positive. And then p to the 4th times p to the 5th, same base. We add our exponents, so p to the 9th. So it's just, think of it like reorganizing. Multiply coefficients and then sort each of your letters. All right, so pause the video, try that for letter D. See if you can come up with what this one would be. All right, so think about our coefficients. So we're going to multiply the negative 7 times the 3. I have an x squared and an x, and then a y cubed and a y to the 4th. And again, this is a kind of a good organizational strategy here. I'll put our coefficients together, negative 21, multiplication. Hey, what is this x worth? If there's no exponent written, that's to the first power. So just don't forget that because then that's going to be x to the 3rd. And then 3 plus 4 would be y to the 7th. So just be careful that you get those ones in there for those powers. So these are the the power and the product rules. All right, let's do those special 0 power ones. Remember, anything to the 0 power is 1. So 29 to the 0 power would be 1. Negative 29 to the 0 power, what do you think? Any base, doesn't matter, raise to the 0, still 1. Okay, so here's my question then. How is letter C different? The base in this one is 29. I raise it to the 0 power. That's going to give me 1, but then if I have this minus sign out front, it means take the opposite. So be careful. No, letter B is different than letter C. In letter B, my whole base had the negative in there. Anything to the 0, that's just 1. If the negative's on the outside, it turns that answer negative. So anytime you have a negative on the outside, just makes your answer negative. All right, so how would you do letter D? Well, what's 8 to the 0? 1. What's 15 to the 0? 1. 1 minus 1? Nothing left. So you can do operations with these as well. Just be careful about what your base actually is. Is the that negative sign included as part of the base or not. All right, let's talk a little bit about negative exponents. They want you to write your answer only with positive exponents. So what that means is they want you to do those reciprocals, put them where they belong. All right, so go ahead for this first one for letter A. Pause the video. How would you rewrite that with a positive exponent? All right, so my base is 6, and I have 5 of them, but the negative means reciprocal. So this means 1 over 6 to the 5th power. Just being able to understand that that's what that's saying. That negative doesn't mean negative number, it means reciprocal. All right, so how would you do letter B then? Let's go ahead and pause. So 1 over, what's my base? Everything in the parentheses, so 2x, and then raised to the 4th power. For the last one, 6 to the 5th gets pretty big. You could write out what that number is too if you want to, that you definitely could, but if they get so large, I'm not even so worried about that. I just want to make sure that you know what the exponent should be. In this one, 2x to the 4th I could probably do. Remember that means 2x times 2x times 2x times 2x. Take everything on the inside and raise it to the 4th. So 2 to the 4th and x to the 4th. What's 2 to the 4th? 2 times 2 times 2 times 2. That's 16, and then x to the 4th. So make sure you simplify. If the number is small enough, we can definitely do that. All right, let's take a look at the next one. This one is tricky for people. This is one of the hardest ones. Which number or letter has the -4 exponent? Only the p. If they wanted the -7 to have that same exponent, they would have had to do it like this with the parentheses. So just be really careful when you look at this. Actually, the 7 has an exponent of 1. So when we think about what's going to move in terms of a negative exponent, the only thing that's moving is that p. So that's going to go into the denominator because it had a negative exponent. The -7 does not. Just because a number is negative, that doesn't mean reciprocal. That's a negative exponent. So we need to keep clear what negative numbers are versus what negative exponents are. The only thing that moves there is the p. All right, so we can evaluate with negative exponents. We just have to know what each of these mean. So 4 to the -1st means 1 over 4. 2 to the -1st means 1 over 2. So when you look at those, it might seem kind of scary looking, but it's just really asking you to do 1/4 minus a half. So if you take 25 cents minus 50 cents, you're a quarter in the hole, or -1/4. If you wanted to, you can also just get a common denominator, right? So we would have 1/4 minus 2/4, which would leave you with that -1/4. So we're going to be evaluating and using things that have those negative exponents as well. All right, so what about negatives in the bottom? Let's go the other direction. Let's see if we can do this. 1 over 4 to the -3rd. So remember, negative exponent in the denominator means reciprocal, so that's going to go to the numerator. So pause and see if you can rewrite that. What would that look like? So that means I'm going to have a 4 cubed. So 4 to the 3rd power, 4 times 4 times 4. So 4 times 4 is 16 times 4 would be 64. You can use your calculator definitely to help you with that if you need to. So when we think about negative exponent in the denominator, it means it goes to the numerator. Oh my goodness, what's happening with this? Let's move everything we can. If you have negatives in both spots, put them where they belong. Where does that 3 to the -3rd end up? That means those 3 3's, that's what 3 cubed means, are in the denominator. Notice positive exponent when you do the reciprocal. This 9 to the -1st, it's in the denominator, so it's reciprocal, 9 to the 1st in the numerator. So again, anything that's negative, we put in the opposite location. So that would be 9 over 3 to the 3rd is 27, 3 times 3 times 3. So that would be, let's reduce, divide by 9 would be 1/3. So if we can get this into lowest terms, that would be great. So negative exponents, remember, means reciprocal, opposite location when we look at those. All right, let's do some dividing now that we've talked about some negatives. Remember the rule for dividing. If you have the same base, you subtract the exponents. We're going to talk about just sort of a, I don't know, more of a common sense approach when we talk about this too, but let's start with the rule. So the rule says subtract the exponents. They're the same base, so that would be m to the 8 minus 13 power. Again, I would not write that all the time, but that would be m to the negative. So m to the -5th. Now we want to write it with a positive exponent though. So remember, we can rewrite that then with our reciprocal 1 over m to the 5th. Now if you like that way, that's fantastic. You're using the rule, that's great. Here's a common sense approach. Take a look back at the original. Where do you have more m's, top or bottom? more in the bottom, right? So how many more do you have in the bottom than you do in the top? 5 of them. That means when you simplify this fraction, you're still going to have 5 m's left in the denominator. So if you think about it from that kind of common sense approach, that's what we're talking about. So think about it like you divided out 8 of the common m's, and then all you had left were the 5 on the bottom. So for a lot of people, that's the way they like to think of it. It's just where do you have more, and then that's where you end up. Let's be careful though. Negative exponents mess with people. So let's get these values where they belong first. Can you take a moment, pause the video, put those 5s where they belong? So this negative 8 power in the denominator means that 5 to the 8th is in the numerator. My 5 to the negative 6 in the numerator is going to be 5 to the 6 in the denominator. So now I can go ahead and do my rule. Same base, notice they're both 5s. That would be 5 to the 8 minus 6, which is 5 to the second power, which is just 25, 5 times 5. Now, if you want to, again, you can do the where do you have more. So look back where they're positive. That's the easiest way. Where do you have more 5s? On top. How many more 5s do you have on the top than you do on the bottom? 2 more, so it's a 5 squared. It's a nice way to think about it for common sense. All right, let's take a look at letter C. All right, you have positive exponents, so we're okay with that. Take a look at the bases, though. What do you notice about the bases? They are different, right? We have different bases, so can you actually divide them? Nope, no common factors. We can't divide anything out. So they're different bases. This is already simplified. We can't do anything with that because they're not like terms. I can't divide out a common factor if I don't have any. So just be careful. Make sure your bases are the same. All right, now we're going to do some power to a power. So we have lots of different rules that we're trying to address, and we're just making sure that we know how to deal with all of these. So power to a power is where you're taking a base that's already raised to a power and raising it to another one. So like r to the 5th to the 4th, what that means is r to the 5th times itself 4 times. Now we could always write that out if we wanted to, but think about it, what if you had like to the 20th power? I wouldn't want to write that out. How many r's do you have all together? Well, 5 plus 5 plus 5 plus 5, that would be r to the 20th. So do you see a shortcut? Do you remember our shortcut rule, power to a power? We multiply the exponents, right? 4 times 5. So it might be a faster way for you to think of it. Also, let's take a look at letter B. If you have multiple bases that are being raised to a power, that means you need to take every single thing on the inside and raise it to that power. So I really encourage you to write this middle step to make sure that you get everything that you need to. That negative 3 has to be squared, and so does the y to the 5th, because that's what it means to square something, right? You're going to do negative 3y to the 5th times negative 3y to the 5th. That's another way you can write your work if you're squaring something. Again, if you did this to the 20th power, I probably wouldn't want to write it out 20 times though, right? So it might be faster to think of it this way. But that's what we're doing. We're multiplying negative 3 times negative 3, or negative 3 squared, which is negative times a negative, positive 9, and then y to the 5th squared. So our shortcut, power to a power, would be y to the, think about how many you have all together here, 10th. Power to a power, we multiply. So just remember, if you have things inside parentheses and you're raising it to a power, gosh, everything in there needs to raise to that power. All right, so we have 3/4 cubed. We're multiplying a fraction and we're cubing it. Most people don't like to do like 3/4 times 3/4 times 3/4. So remember, when you're dividing, it's the same deal. We can split up the top and the bottom, and that's so much easier for people to think about. We can just do integers and raise them to powers. So 3 cubed, that's 27. 4 cubed, 64. It still means we just did 3/4 times itself 3 times, but it's just a faster way, I think, to think of it. So we can split up the top and the bottom. And again, it's just like letter B. Everything inside has to be cubed, so the top and the bottom. All right, what do you have an exponent on a fraction, just like the last one, but it's a negative. What does that mean? Okay, well, there's a couple ways to think of this, but again, we can do exactly what we just did for the last one. It means that everything on the inside has to be raised to that negative 4th power. So everything on the inside, top and bottom, all raised to that same power. So let's get the numbers where they belong then. That 2 to the negative 4th means we have a 2 to the 4th in the denominator. 3 to the negative 4th in the bottom ends up to be a 3 to the 4th in the numerator. So then again, it's easier for us to calculate that. 2 to the 4th, 2 times 2 times 2 times 2. That's 16. 3 to the 4th. 3 times 3 is 9. Another 3 times 3 is another 9. And then 9 times 9? 81. Might be an easier way to break that up in your head to try to do that multiplication. Now, here's what some people do right away. So if I see this, maybe what I would do right away, instead of doing this negative step and then switching it, some people will look at this and say, okay, -4 means reciprocal. What's the reciprocal of 2/3? Well, it's 3 over 2, and then I'm going to be raising that to the 4th, and then they're going to do 3 to the 4th over 2 to the 4th, which is exactly what we did as well. So some people just flip the whole thing right away. Some people write them individually first and then flip. Ultimately, the negative exponent means reciprocal. You can do it either way. All right, let's put it all together. These last questions are going to be kind of a cornucopia of fun here. We're going to do a whole bunch of different things. Positive and negative exponents, power rules, everything. All right, so let's take a look. And again, pause each one before I talk it through so you can try it. So for letter A, give it a whirl and then come back and see what my answer is and compare it with yours. All right, so we have 4 squared to the -5th. So power to a power, we multiply the exponents. So 2 times -5 would be -10. And then remember, you want your final answer with a positive exponent. So 1 over 4 to the 10th. So power rule and a negative exponent. All right, so for letter B, give it a try and then see what we come up with. So we have all bases are the same, so we can add the exponents. So we need to do a -4 plus a -6 plus an 8. They're all the same base. So the negatives together would be, looks like -10 plus 8 would be -2. All right, so now remember, only positive exponents, so how can we rewrite that? Well, that's 1 over x to the 2nd power. So we're always trying to think positive exponents for our answer. Oh dear, look at all this. Okay, a little bit of a challenge. See what you can do with this one. Pause the video. Let's talk through each of the steps and see if we can simplify that, because that looks like kind of a disaster. All right, so order of operations, this big fraction bar is like a grouping symbol. So I'm going to do anything I can on the top, anything I can on the bottom, and then see if I can reduce at the end. Denominator is not a whole lot to do because I like putting those two terms together anyway because they have different bases. But we can do some things up here with this squaring, this power and then to the -2nd. So everything on the inside is going to have to raise to the -2nd. So we're going to have to take m squared to the -2nd and then n to the -2nd. All right, I'm just going to move this so I can move my screen up here when I need to get a little bit more room. All right, let's do those powers on the top now. So m squared to the -2nd, power to a power, we multiply. So m to the -4th times n to the -2nd. And on the bottom we have m to the -3rd and then times n. Now what I would probably do next, just because this is easier for me, is I like to put terms, everything positive exponents. So get them in the right spots. So this m to the -4th, that's going to come down to the bottom as an m to the 4th. This n to the -2nd, it's also going to come down as an n to the 2nd. So all I have left in the numerator then right now is just a 1. All right, because the coefficient of each of these would be a 1, right? So 1 times that. In the bottom, I have an m to the -3rd. That's going to come up top because it was a negative exponent in the bottom. N to the what power is that again on the bottom? First. Notice that's +1, isn't it? Regular old 1. It doesn't move at all. The only things that move are reciprocals that have negative exponents. It doesn't. It's a positive. It stays put. Okay, so is there anything we can do? Numerator, I think that's just set for right now. On the bottom, those are like bases. So we have an m cubed over m to the 4th times n to the 2 plus 1, n to the 3rd. Okay, last thing, take a look at dividing out common factors. M to the 3rd, m to the 4th. Where do you have more m's? On the bottom, how many more? 1. So that means I'm going to have an m to the 1st left on the bottom and an n cubed. And remember, there's a coefficient out front of each of these terms of a 1. So when you do reduce that, it would be 1 over. It's kind of like doing 2/4. When you reduce that fraction, you divide by 2 top and bottom. You don't just say 2, right? It's 1/2. So it's the same idea. Just be careful. There's lots of little places where that could go haywire. So get those negatives in the right spots. Look for like terms and then see what you can divide out at the end. All right. We'll try letter D. We'll do the same thing. So pause the video, give it a try, and then come back together and I'll do an explanation. We'll talk this one through. All right, order of operations, I see grouping, but there's nothing I can simplify inside the grouping. So it looks like I'm going to have to do exponents next. So I'm going to do the squaring here and the -1 there. So squaring means everything on the inside gets squared. So I need to do this on that first one. And then for this, everything needs to be the negative first power. So the 4y needs to be the negative first, and the x needs to be the negative first. So I'm just writing what powers I'm going to do. So I'm squaring everything in the first one, and I'm doing everything to the negative first in the second one. All right, so what does that mean? Let's do some simplifying here. 2 squared, that's 4. Y squared is just y squared. Down at the bottom, shortcut here, x cubed squared. Power to a power. Remember that means like x cubed times x cubed. So 1, 2, 3, 4, 5, 6 would be x to the 6th. And then over here, negative exponent means to just do the reciprocal. So if I have x to the negative first in the bottom, that comes up to be x to the first. If I have 4y to the negative first in the top, that means I'm going to have a 4y in the denominator. So just make sure you get, that's all that means. A negative first power is still the first, but just reciprocal. All right, let's put together what we have here. Looks like in the numerator, if I multiply across, I have a 4y squared x. And in the bottom, I have an x to the, well, actually, let's put the 4 first. That'll be a lot easier. The 4y times x to the 6th. You can write the terms in whatever order you want, but sometimes I think it's nice to have the numbers first. All right, so let's see if we can reduce that fraction. So 4 divided by 4, sweet, that's a 1. Look at the y's. Where do you have more y's? On the top. By how many? 1. In other words, 2 minus 1. So we have a y to the first in the numerator. Let's take a look at the x's. Where do you have more x's? On the bottom. How many more on the bottom than the top? 5 of them, or x to the 5th. So we have simplified this all the way down to y over x to the 5th. Being able to work with exponents and handle exponent rules is really critical moving forward and being comfortable with those. So that's really where we're going to be putting a lot of our time and energy, is being able to feel confident that we can work with these exponents. So practice does make better for sure. So we're going to keep working to see if we can get those exponent rules nailed down.